Hi, everyone. You can hear me well? It's not too high. Okay. Well, my name is Jovana Palibrk. I'm a solutions engineer at Kentik. And today I will be talking about RPKI adoption and milestones we achieved this year. Before I start, I want to stress that this presentation is actually originally made from, by Doug Madori. Doug Madori is our director of internet analysis. So he's a guy who tracks the events on the internet and then uses Kentik aggregate data to analyze those events further. And if you do not follow him so far, please do, because he has always something interesting to say. And yeah, today's analysis is actually his analysis, so. All right, talking about RPKI deployment, I would like to start with two important steps of the RPKI deployment. First one is creating ROAs for the BGP prefixes. So basically making sure that we know what are the networks that should originate those prefixes. And the next step is apply actually the rules once that those ROA informations are not being tracked in the BGP updates. So in other words, let's reject the BGP routes which do not have this information valid. And further on, I will call these routes RPKI invalid routes. And during the presentation, I will actually come back to these two steps quite often. Why is Kentik talking about this? So for you that don't know, Kentik is a network observability tool. And among other stuff, we actually provide traffic analysis based on flow data. And I'll go back to 2019 when Job Snyder, and I hope you all know who he is, actually made a call out to traffic analysis tools to add a feature which will allow customers to track what portion of their traffic will be impacted if they would start rejecting RPKI invalids. And yeah, Kentik was challenged by that call out and we accepted the challenge. So in 2020, we added that feature to our portfolio. And actually the rest of this presentation, the analysis that I'm going to present is what we've learned since, thanks to that feature and some other information. All right, so going back to ROA adoption, right? We started that with prediction. So what Doug wanted sometimes last year is to predict the date when a number of routes which actually have ROA and are valid will meet the number of routes that do not have ROA. So ROA doesn't exist. We don't know if they are valid or not. And his prediction at the time was that in May 2024, so May this year, that number will be the same. And then hopefully after that, they will part ways. What he did as well is ask the community what they think. And people were not as optimistic as he was. So the most of the people actually chose later dates than May 2024. But what actually happened is that we did meet that milestone. So 1st of May 2024, the number of RPKI valid routes was a little bit higher than the number of RPKI routes that do not have ROA at all. And here you can see the number. It's taken from the NIST RPKI monitoring tool. All right, so those are routes, BGP route stories, right? another next step, which we wanted to check, was how that reflects the actual traffic. And for that, we have used Kentik aggregate data. We actually did this measurement in the past, and we have the newest measurements. So here I'm going to actually compare the two. This measurement here is from February 2022. At that time, the number of PGP routes with ROA was 1/3. And the traffic that was following those routes was just above 50%. Here you have the actual number, 56%. October 2024, so now we know that we have more than 50% of the routes with ROAs. That actually means that 73.4% of the traffic follows these routes. So basically, the traffic that is eligible for protection following RPKI infrastructure is actually quite significant. So the percentages are bigger than the routes themselves. Let's see what is the situation in Spain, since we're here. Let's start from this graph here. So this graph here is the history of IPv4 routes with ROAs. And we had actually a steady 40% for some time. And then things changed in January 2024 when people started, companies started deploying RPKI a little bit more. And no? Okay. I was about to ask if anyone has a theory why. Okay. I don't know neither. So we have, since that moment, an increase of the number of routes that actually adopts ROA, has the valid ROA. Took a few months, and Spain reached 70%, so pretty good. 70% of ROA valid routes means, and this is the other graph here, means 86% of the valid traffic as well. So again, the impact on the traffic is quite significant. And that puts Spain on the nice 5th place in Europe, right after Portugal, France, Germany, and Netherlands. So just to clarify once again, the red bar is the percentage of the ROA, RPKI valid routes, so 70%, that was the previous picture. And then blue bar is the percentage of the traffic following those valid routes, right? 86%. So pretty good numbers for Spain. And here you have the actual networks that contribute to those routes. So I put the numbers, hope you all know who they are, or you can recognize yourself. But yeah, the numbers are pretty high, so well done. All right, so this was the first step, right? From the beginning of the presentation, we need to have the routes that will actually have ROAs signed. And then the next step was the networks needs to reject the routes that do not follow ROA information, so RPKI invalid routes. Why? Well, because we want to reduce the propagation of the RPKI invalid routes. That's the whole point. We don't want them in our networks, right? And these graphs here actually show, well, a graphic. These are the graphic examples. How is that important? So we have for IPv4 and IPv6 analysis, and on the x-axis are the number of route view vantage points, because this is what is used for this analysis, that see the routes, And here we have, so on the y-axis, we have the actual number of the routes. Which routes? So the first graph is focusing on RPKI not found. We don't have ROAs. Second, RPKI valid. ROAs are there and the routes are fine following them. And finally, RPKI invalid. So the distribution for the RPKI not found and RPKI valid actually goes towards right. And it makes sense, right? Because no one is rejecting them. So majority of the vantage points of the routers in the internet see them. So that's fine. And for the RPKI invalids, we want them to be as left as possible, right? Because we want fewer number of routes to actually see them. Hopefully none of them. And this was the situation, this was the situation from August 2022. So what we did next is we took these numbers for RPKI invalids, this is our focus. We took these numbers from 2022 to 2024 and made a graph that shows the progress that was made in those two and a half years. So here, now we have the number of route view vantage points that are seeing the route, and here we have the timeline. And we can see that through the time, less and less routers are seeing the RPKI invalids, which is a good trend. This is what we want to see. But this analysis itself has several challenges. First challenge being that those routes that we are counting here are variable, so not always the same routes are being counted because they're changing. Things are being fixed, some other things are being broken, so we are not following the same group. And then the other one is that actually the propagation of the route really depends on the networks that are transiting those routes. So in order to see indeed with all these challenges if the trends are like this, we decided to follow the beacons, RPKI invalid beacons. Those are basically prefixes that are intentionally made RPKI invalid and sent to the internet so we can follow how many of the networks see them. And we use the RIPE beacons, IPv4 and IPv6. And we also were following the Job-Snyder's beacons. Here on the graphs you can see the propagation for the valid ones and invalid ones. So I'm going to focus on the invalid ones, right? So invalid ones are showing the downtrend. It's actually very similar to the previous one, right? So if we take away all these challenges, the trend is still going down. That's a very good good thing. Now, for Job-Snyder's, there is some interesting observation, right? Because he has two invalids, right? And if you check the graph, there is a slight difference between the two. Maybe here you can see it even better. So there is a discrepancy. So let's have a look at those two. So the green one is 209. It belongs to Erin, so it's a route from Erin registry. And the other one, 194, is from the RIPE registry. So what we are observing here is that the route from the RIPE registry, actually invalid route, is present on less vantage points comparing to the Erin one. And why is that? Well, apparently, Erin has a very lengthy party agreement that needs to be signed, and there are a number of companies of the network that actually don't want to sign this agreement for this or that reason. So, not signing the agreement means that those companies do not consider these ROAs at all. So for them, they are unknown, right? And that makes this difference here. So basically, more networks are seeing these RPKI invalids. They're being propagated more, meaning that ARIN managed IPs, well, signed ROAs by ARIN are a little bit less sufficient than RIPE in this case. So another thing that really influences the adoption and then RPKI invalid propagation. All right, so another thing that we were looking at and actually we were able to give really good examples of is, yes, we want networks to reject RPKI invalids. In the perfect world, all of them, but that's not going to happen. So does it matter who actually rejects RPKI invalids? And we think it does. And we think that actually big service providers are the ones who should have that responsibility because they are carrying the most of the traffic and they should protect the other networks. And this is the example which kind of proves it. The picture that you are seeing here is actually a screenshot from Kentik, BGP monitoring tool. What you see on the lower part is the AS path for a specific prefix. This is the prefix. You can actually see it here as well. So we were following this specific prefix. We were checking the AS path using the route view vantage points again. And originating ASN of this prefix is marked red because it's invalid. So this is invalid RPKI route. Now here you can see a propagation of that route. Percentage of the vantage points on the internet that actually see this RPKI invalid. And if you check the number here, I don't know if you can see it, it's 50%, so close to 50%, I don't know, maybe this is 40, 45% of the vantage points were seeing this RPKI invalid route. This here is the graph from 1st of April, 2024. So what happened on 1st of April, 2024 is actually that Zayo decided to deploy RPKI, to reject RPKI invalids from their customers. So up to that point, they were rejecting it from their peers. However, their peers were doing quite a good job, so there was not much to reject. And 1st of April 2024, they started rejecting RPKI invalids from their customers. And just on this one example, we can see that from that moment, the percentage of the routing view routers that are seeing, well, that are not seeing this RPKI invalid anymore dropped about 16%, right? So Zayo really has an impact. And this is kind of proving our point, right? So it is important who is rejecting RPKI invalids, and it's a responsibility of these big providers to protect the rest. So just to recap the milestones so far, 1st of January 2024, 1st of April 2024, we now have quite a good state of RPKI adoption, and this is now a situation from June 2024. To give a little bit of context, I'm going to go back to Doug. So what Doug does, he's tracking the IP prefixes on the internet, and he identifies the prefixes that probably have ROA misconfigured. Now, misconfiguration is not on the originating part, it's actually on the prefix length part. It happens, right? So prefix length is defined, and then after some time, networks change the policy, how they're going to do it. They forget to change ROAs. So those prefixes then become RPKI invalid, and they are being basically discarded, rejected by the networks. When Doug sees this, when he notices those prefixes, and if those prefixes belong to our customers or prospects, we inform them about it. And this is example, actually, of that situation. So Globe Telecom, we informed them about their prefixes. They fixed it, and we were tracking the situation. So now you know this screenshot already. You know what it presents. This is the prefix, which was, before this moment, invalid. And it wasn't visible. It was visible, I think this is maybe 15–20% of the route view routers. When they fixed it, so ROA is configured now properly, very soon, of course, almost 100% of the routers was able to see it. So this actually shows that, yeah, the propagation of the RPKI invalids later on was pretty good, right? Thanks to all these milestones we achieved. Another interesting analysis to this route, BGP route analysis, is how did that impact the traffic, right? So I'm going to go back a little bit to that story. This is another screenshot from Kentik, where we were following what happened to the traffic routed to this specific prefix. And yeah, we actually saw the increase of the traffic, which kind of also makes sense, right? Because the prefix was available on most of the internet at that moment. Yeah? All right. So I'm going to repeat it. As I said, I will many times. So it is important to reject RPKI invalids. Most of the prefixes have ROA. Let's use it. And the second one, let's create ROAs for the rest, right? So let's get more than 50.8% where we are at the moment. The conclusions from this analysis is basically that now we are at a very good place with 50% of the routes following ROAs and 75% of the traffic actually following those routes. Good point was that Zayo did the RPKI invalid rejection. We saw how that impacts the situation. But we know that this is not enough, right? So RPKI by itself, it's not going to solve the problem. It will make life for some harder, but not impossible. And the proof for that was the attack against cryptocurrency company in 2024, if you know about it, where they actually work around RPKI infrastructure. So it is possible still, but we do have this infrastructure which can be our starting point, and then we definitely have to work further towards the secure routing on the internet. So yeah, that's it. Thank you. Any questions?
¿Alguna pregunta para Jovana? Ya. Ya vengo, no te preocupes.
Hi, you mentioned, and I agree with you, that it's not the same to have a big ISP filter than a smaller one. But do you think it is a good idea to have a tier 1 filter? Because I kind of think the opposite. I think that filtering, just like prefix filtering, should be done closer to the customer. Because if you do it in the center of the network, yes, you have a big cone of shadow of protection. But if you have a problem, there's no way to solve it.
No, absolutely. And that's why I started really that slide carefully with we do want everyone to do it, right? Mm-hmm. That's the perfect world, but we saw that there is a difference if tier 1 customers are, tier 1 providers are doing it. So that was the Zayo example. Mm-hmm. So no, I totally agree, but we are not there, right? So okay. We're doing analysis on the state where we are at the moment.
Sure, it's just sometimes we have our own measures at IPNIC, and sometimes having bigger numbers seems like a good thing, but in practice, operational, It might not be. It might be quite the opposite.
Yeah, I agree.
Thank you, Joe.
If I'm not wrong, Jovana has a question, right, about the slide number 12. What happened in Spain that day in January?
Sorry?
Yeah, you know or not?
Which one, sorry?
Oh, in the slide where you show that RPKI in Spain rised in a strong way.
This one?
Yes, you know
Yeah.
why?
Yeah, I do know why.
You don't know why?
I
think
do
the
know.
audience is happy to explain you. I think that something happened with an orange company here in Spain, and
Oh, really?
in a following. No. I'm not talking about Hessen, Germany. No, I'm talking about Spain. And I also saw that in the following slide there is a 100% from 12,479. That's a great achievement. I think that is the push for RPKI. If all the operators will impact in that way, I think that RPKI will become 100% for all.
Thanks.
There is nothing better than a perfect crash to make things happen. Yeah. Okay, thank you very much. Any other question here? See?
Is there, you mentioned that there are invalid rows due to the length of the prefix announced.
Yes.
So you can measure the prefix and you can check against the row and the AS, origin AS.
Yes.
Is there any study or any task force that promotes or announces to the affected AS that something is wrong and it has to be fixed in order to work fine? Or?
Yes, so that's this example here.
Exactly.
Yes. So we are able to see if it's the prefix length or the origin, but what we are doing in that regards is actually what Doug does, right? So he does this analysis with his team, and then he basically sends the analysis individually to the networks where this is happening. So this is what we are doing currently. And of course we're doing this if those networks are our customers or prospects.
Okay, thank you.
Gracias. Any other question? If not, then thank you very much, Jovana.
Thank you.